Welcome you all. Today we are going to see the title Modbus, which comes under the subject title Industrial Data Communication. What is Modbus protocol? Modbus, developed by Modicon in 1979, is a means of communication with multiple devices through a single twisted pair. At first, it worked on RS-232, but then it is used for both RS-485 to get higher speed, longer distance and multi-drop network. Modbus has quickly become a common standard in the automation industry, and Modicon has launched to the public as a free protocol. Modbus is a master-slave system. Master is connected to one or more slaves. Master is usually a PLC, PC, DCS or RTU. Slave Modbus RTU is usually a field devices, all connected to the network in multi-drop configuration. When a Modbus RTU owner wants information from the device, it will send a message about the data needed, summarizing the error detection to the device address. All the other devices on the network will receive this message, but only the specified device will respond. What Modbus standards are in common use? Currently, there are three Modbus standards that are commonly used in industry automation: Modbus RTU, Modbus ASCII, Modbus TCP. All data are sent in the same format. The only difference between the three Modbus types is how the data is encrypted. Modbus ASCII. All data is encrypted using hexadecimal using 4-bit ASCII properties. For every byte of information, 2 communication bytes are needed, double that of Modbus RTU or Modbus TCP. However, Modbus ASCII is the slowest of the three types of protocols, but it is suitable when the telephone modem or the connection uses radio waves because ASCII uses message identification features. Because of this delineation feature, any trouble in the transmission medium will not cause the receiver to misinterpret information. Modbus RTU. Data is encoded in binary and only needs one communication byte per data byte. It is ideal for RS-232 or RS-485 multi-point networks ranging from 1200 to 115 baud rates. The most popular speeds are 9600 to 19200 baud. Modbus RTU is the most widely used industrial protocol, so most of this article will only focus on its basis and application. More details on the Modbus RTU protocol can be found here. Modbus TCP. Modbus TCP is simply Modbus over Ethernet. Instead of using this device for connecting to slave devices, so the IP addresses are used. With Modbus TCP, Modbus data is simply summarized in a TCP IP packet. Therefore, any Ethernet network that supports Modbus IP will immediately support Modbus TCP. Modbus is a request response protocol implemented using a master-slave relationship. In a master-slave relationship, communication always occurs in pairs. One device must initiate a request and then wait for the response. And the initiating device, that is the master, is responsible for initiating every interaction. Typically, the master is a human machine interface or HMI or SCADA system, and the slave is a sensor, PLC or PAC, programmable automation controller. The content of these requests and responses and the network layers across which these messages are sent are defined by different layers of the protocol. Differences between RS-232 and RS-485. RS-232 and RS-485 both are the standard protocols of serial communication which are used to send and receive data. It is developed by EIA, that is Electronic Industries Association, or TIA, Telecommunication Industries Association. The main purpose of a serial interface is to provide a single path for data transmission. A serial interface is a very good option for communication over any distance greater than several feet. There are certain points at which RS-232 differs from RS-485, such as communication distance, immunity against electrical noise on the ground, number of devices and data transmission speed. Communication distance. It can communicate a sender and receiver over a maximum distance of 15 meters in RS-232. However, a cable length can be extended but with a slower data communication speed. For RS-485, the communication distance between sender and receiver is remarkably longer, up to 1200 meters. That is for better than RS-232, and it could be the main reason to pick RS-485 over RS-232. Immunity against electrical noise and ground. RS-232 operates on a single-ended line technique that performs well while using with a minimal ground potential. However, in electrically noisy environments with different potential levels, RS-232 is too fragile and allows data corruption. Whereas in RS-485, it offers higher noise immunity as it operates on a differential voltage system, which allows it a longer data transfer distance. Lower voltage use of RS-485 offers a higher data speed. Number of devices. RS-232 has only 2 devices in a network. One is sender and the other is receiver. Whereas in RS-485, it is designed for a multi-point system and it can connect up to 32 devices to a single transmitter. Data transmission speed. RS-232 can transmit data with the speed of 1 megabit per second over a distance of 15 meters, while RS-485 has a data transmission speed of up to 10 megabit per second up to a distance of 15 meter. Although it can transmit a data up to 1200 meter with a speed of 100 kilobits per second. So overall summary, it can be said as RS-232 has an advantage when short distance and low speeds are required. It is a simple and low cost interface. When you want a simple communication interface between two devices, only 2-pin full duplex communication is easily established using RS-232. Whereas in RS-485, it provides a higher speed over a longer distance, so it is used generally in a network with a multiple devices up to 32 devices in a single network over a longer distance. So the Modbus standard can be represented as Modbus RS-485 RTU, where Modbus is a protocol and RS-485 is electrical standard and RTU is the mode of transmission. So the messaging frame for RTU consists of slave address which has 1 byte and function code which has 1 byte and data which can up to be 252 byte and the CRC cyclic redundancy check which can be up to 2 byte. Whereas in ASCII messaging frame, it has a start bit as 1 character and slave address as 2 character, function code as 2 character, data can be up to 252 characters and CRC of 2 characters and end is 2 character. So the Modbus communication parameter, whereas we call as a common parameter between master and slave, can be baud rate, data bits, stop bit and parity bit. So in baud rate, when the master has connected to 9600 bits per second, the slave should also to be at the speed rate of 9600 bits per second. So there are various bits per second can be used between the master and the slave. The standard baud rate is 9600 BPS. Whereas in data bits, there are 2 types of data bits which can be used for the frames between master and the slave. It can be 7 or 8, but the standard data bit is 8. Stop bit, there are 2 types of stop bit is available, 1 or 2. So here the standard bit can be 1 or it can be 2. In parity bit, there are 3 types of parity. It can be even parity or odd parity or the non-parity. So the standard parameters between the master and the slave can be baud rate is 9600 BPS, data bit is 8 bit and stop bit is 1 and parity is none. The unit ID for the master will be 1 and it can up to connect to 32 slides. So it can be 1 master and 31 slaves. The address ranges can be 1 to 247. So accessing data in Modbus and the Modbus data model. Modbus accessible data, it can be stored in general in one of the 4 data banks or in ranges of coil, discrete input, holding register and input register. As with much of the specification, the names may vary depending on the industries or the application. For example, holding register may be referred to as output register and coil may be registered as a digital or discrete output. So, these data blanks define the types and access rights of the contained data. Slave devices have direct access to this data, which is hosted locally on the devices. The Modbus accessible data is generally a subset of the device main memory. In contrast, Modbus master must request access to this data through various function codes. So, the behavior of each block is shown in the table. So, the memory block can be coils, the data type will be Boolean, the master access will be read or write, the slave access can be read or write. For the memory block discrete input, the data can be Boolean, the master access is read only, the slave access will be read or write. For the holding register, the data type is unsigned word, the master access is read or write, the slave access is read or write. For the input register, the data type is unsigned word and the master access is read only and slave access is read or write. So, the common parameter between the master and the slaves are baud rate, data bits, stop bit and parity bit. Whereas, in Modbus parameter between the master and slave will be unit ID, slave ID and function code, data, address, data type and data formatting. The applications of Modbus. Application of Modbus is a multi-master slave application to communicate between smart devices and sensors and the instruments to monitor field devices using desktop PC and the human machine interface. Modbus is a perfect protocol for RTU related applications in which wireless communication is required. Thank you all.